Can you explain solid state starter? Let me back up. This is a form of soft starting. That is the core principle to using a solid state starter. We want to do a soft start on our motor, which means that with an electrical mechanical starter, okay, the contactor in a regular split system, an RTU that just closes, compressor turns on, that is an XL starter. It's just small contactor. And that is true once we scale into a much larger application where we may have a genuine large starter block, but it's just one of them that is a XL start. And XL is literally referring to cross line. So X is cross on electrical schematic. That's what that is referencing. We say X because it's a cross. So cross line, and L referring to line. That is your cross line starter, XL starter. That's the most basic version. That is a hard start. Okay, not a hard start kit with a capacitor and all the other stuff, right? So it is a hard start in the fact that it just slams closed and you get full line voltage straight to the motor, and it better hang on and hold its ass, and it's going to take off and go. So that's really difficult on the motor itself. That puts a lot of stress on it. You have a really high peak in the starting current, right? And it also costs a lot of money to do that once you get to a large enough scale, because starting a large motor like that across line takes a lot of energy. So by having a solid state starter, it is a type of soft starter. So there's various types, but let's hone in on solid state. So what makes it solid state to begin with? Typically we're using an SCR, a silicon controlled rectifier. Now, SCRs can be implemented in a variety of ways. So this will be one form of a solid state starter. We have a electromechanical starter. So here's your XL and here's your SCR. So we can use this over here as a better example. So this is one form. This is probably the more common form, especially on smaller equipment. So what we're doing here is we have these SCRs, and in this particular application, we want to use these SCRs to slowly apply power to the motor, so that instead of having a huge inrush of current at start, we gently apply power to the motor to allow it to slowly come online. So the way we're doing that is we have our input lead. So we have 3 SCRs here. So in this particular case, be a 3-phase system. Each leg of power, so L1, 2, and L3 coming into post number 1 on this SCR. And we have post 2 and post 3. So if we were trying to do a VSD rectification, then these post 2 and 3 would be separated, but that's not what we're trying to do. We're trying to use this as a gradual pass-through where we can cycle this SCR gate rapidly and gently apply power to the motor. So you'll see that there's a bus bar that connects the positive and negative. So that's what these 2 and 3 are. They're a positive and negative bus. And by putting a bus bar between there and then connecting our motor leads to the other side, here, here, and here, we can maintain our AC output. This confuses some when they're used to like the drive perspective here. So by combining the 2 outputs, we maintain our AC output through the SCR, but we can control how much output comes out of it. So we can gently apply power through these 3 legs to the motor and get that motor to slowly spin up. And then when I say slowly, this is still happening in a matter of seconds, okay? This slowly in relation to this freaking thing just slams closed and it has to haul ass, okay? Slow in relation to that. This is instantaneous, this is slow. That's what I mean as a perspective. This isn't going to take several minutes to accomplish. This is going to take a few seconds at most, if not 1 or 2 seconds. But it's still far less energy and far less stress on the motor than trying to just slam this starter contact closed. And so once this particular style of starter, once the SCRs have gotten to where they can stay fully closed. By fully closed, that means they're just acting as a pass-through device. They're no longer adjusting how much power is going through them. Once they've fully closed and the motor is technically at speed, then we will transition and we can close the starter here to have just the hard mechanical contact, and then we can open these up to allow these to come out of the load circuit. And so you'll have a transition process between the SCR and the mechanical, the electromechanical starter. But again, we gently bring the motor in, which is the whole is the soft starter part of the solid state. But the solid state component of this is the SCRs. This is what makes it solid state, versus a Y delta starter uses 3 of these starters to accomplish a similar effect, but we do it across by reconfiguring how the motor windings are configured, from going from a Y configuration to a delta. That's what we're doing with a Y delta starter, where in this application we can do that. We can even more gently get the motor online than what a Y delta soft starter could do by applying solid state devices. Now, these cannot stay in the electrical circuit for an extended period of time in this particular application, because these SCRs they generate a lot of heat by passing that much current through them. They're mounted to a cooling plate. This is a cooling fin, and you can see the thermal paste right here on the bottom of the SCR as a heat sink. So there is some passive cooling happening from the SCR to this plate, but it's very limited, and it's only designed to keep them cool enough to get past startup. Once you get past that, there is not enough thermal mass here and enough cooling system to keep these in the circuit. They will burn up, versus a larger centrifugal, kind of an old school style. Let's see if I can pull up a example of that, where we've got an active control system, or a cooling system, to prevent the starter from overheating. So this would be a type of, there is no bypass contact here. These are SCRs, they're just much bigger, and they have a steady output, but these are mounted to a cooling plate assembly. Now this would be a liquid cooled style of system, where we're flowing a fluid through a heat exchanger, and it's taking the heat away and rejecting it into the condenser water side of the system. So this is how we would cool a larger set of SCRs if these were to stay in the electrical cycle. So these are not meant to cycle over to electromechanical. These can stay in the cycle, and once they fully close, they're just closed. They don't do anything else. And over here, your positive and negative terminals are tied together internal here. So unlike the other style I showed, they were separated into 2 different terminals because they're just using a standard off-the-shelf SCRs. These are more specific built to this application, to where internally here the positive and negative buses are tied together to rejoin our AC sine wave back together on the output side. And we have our line voltage coming in, but these can stay cool enough. Without getting crazy into the electrical schematics next and diving into that aspect of it, that is what a solid state starter is accomplishing. We're flowing through an SCR to slowly ramp the motor to lower the inrush current, so that we save energy and we put less stress on the motor. And then depending on the style, we either transition to an electromechanical, or we transition, or we have enough cooling on the SCRs to lock it in. There are a lot of solid state starting systems still out there that they're still using bypass contacts. That's what the mechanical contact would be considered, as a bypass contact. It is there for after the SCR has gotten the motor up to speed, we transition to the bypass contacts, which will then just carry the line current from there, and we can bring the SCRs out of the circuit. And by doing that, we don't need the cooling system that we need if the SCRs were to stay in the circuit. And so that is one justification for having a bypass contact involved in the first place. And these are the kind of things I go completely in depth into this, and I take a lot more time to really break this down, show you more examples and stuff inside of Chiller Academy. This is in the certification course specifically. I've got a whole section in there on SCRs, how we apply them, and soft starters, and the different applications we have for stall starters, how we cool them. Like everything we've talked about here, I go in to really good detail inside of that course. So if you're needing more of this type of education and stuff, I would recommend moving or checking that out, seeing if that's a good fit for you and the education that you're looking for to help you. If you're not already in Chiller Academy, I'd really encourage you to go check it out. Just think about it, right? This is what I do full time. I've committed. I've stepped out of the field, committed my career to this going forward. This is what I've always wanted to do, and to be able to educate, help others, and grow, and help this industry take steps forward. So chilleracademy.com. Like I'd love to be able to work with you over there. We've got a community page. All the lessons have a comment section. That's what I spend a lot of my day doing. If I'm not working on the lesson material itself, then I am in the comments and I'm trying to respond to those as fast as I can, in addition to helping you through email and otherwise. So love to be able to work with you. For all of those that are in the academy, y'all are doing some great work out there. Keep it up. I really appreciate the support and the feedback that you've given.